Hi everyone, today I'm going to talk about the turning effect of forces. Forces makes things accelerate in a linear direction. That's what we have learned from Newton's second law. In addition, forces also can create a turning effect. You should have seen a seesaw before. If say you sit at this corner of a seesaw, you are going to exert a force, which is your weight, which is roughly say 700 newtons, and this force will create a turning effect in the sense that the seesaw will now rotate in a anti-clockwise direction. This is what I meant by forces creating a turning effect. Now, for a turning effect to be present, an important criteria will be this point, which is what we call a pivot. I'll usually label a pivot in a diagram using a P. A pivot is a point where the whole system rotates about, and a pivot do not rotate together with the rest of the system. We give this turning effect of forces a name, and we call it moments. The moment of a force can be calculated by using this equation, equals to the force multiplied by the perpendicular distance. And what is this perpendicular distance? The perpendicular distance from the line of action of the force to the pivot. I'll illustrate what this means using the seesaw example above. So the moment of the force caused by my weight acting on the seesaw is simply just the force, which is a 700 Newton force, multiplied by the perpendicular distance. How do I find this perpendicular distance? I must first find out the line of action of the force. So looking at the green dotted line, I am drawing out and extending the line of action of the force. This is what you should do also. When you look at a free body diagram, you find the force vector that you are interested to find moments of, and you extend that line using dotted straight lines. Now, the next step, I would use a set square, which is that triangular piece of geometrical equipment that you have in a mathematical set. I'll use a set square. I'll line up the set square on this line of action. I've drawn a set square in the diagram. I will shift the set square along this line of action until I'm able to find this distance. If you notice, this distance that I've drawn is the perpendicular distance from the dotted line to the pivot, and this distance is the distance that I'm interested in. So say if the length of the seesaw is say 2 meters, half of the length will be 1.0 meters. Therefore, the perpendicular distance from the line of action of the force to the pivot in this scenario caused by weights is 1.0 meters. And I will get a turning moment of 700 Newton meters, which is the unit for moments. We need to define the direction of this moment. As I've said previously, weight acting on the seesaw about this pivot will create an anti-clockwise turning effect about the pivot. Therefore, the moment of this force is 700 Newton meters, anti-clockwise rotation. Let's try to apply what we have learned on another example. So I've drawn for you this structure, and I'm going to tell you that there is this force acting on this structure. Let me call it F1. And there is another force acting on the structure in this direction, F2. And we are supposed to find the turning effect on this structure caused by F1 and F2. So first step, always have your diagram being sketched out with the forces. Step 2, always figure out where is the pivot point. So in this case, the pivot point is here. I'll label it with a P. Next, let's figure out the turning moment caused by F1. Moment caused by F1 is equals to the force itself multiplied by the perpendicular distance. So to figure out the perpendicular distance, first thing first, find the line of action of the force. Next, using a set square, figure out the perpendicular distance from the line of action to the pivot. So shifting my set square around, ultimately I will find that my set square will be in this position. This means that this distance, labeled in red, this distance will be the perpendicular distance from F1 to P. And there you go. F1 times D1 will give you the turning moment caused by F1. This turning moment will make the whole system rotate in this direction, and therefore this is a clockwise moment. Now, F2, the moment caused by F2, same thing goes, equals to the force F2 multiply a perpendicular distance. Let's find this perpendicular distance. Number one, I will extend this line of action of the force. And number two, I will find the perpendicular distance of this line of action from the pivot. This will therefore be the perpendicular distance D2. And force F2 about the structure will cause the system to rotate in this direction about the pivot point. This is an anti-clockwise direction. So there you go. The moment caused by force F2 is simply F2 times D2, and this moment is an anti-clockwise moment. Ultimately, what will happen to this structure? Will it rotate in a clockwise direction? Will it rotate in an anti-clockwise direction? Or will it not rotate at all? Depends on how these two values compare. If the clockwise moment is bigger, then the whole structure will rotate in a clockwise direction. If the clockwise moment is exactly the same as the anti-clockwise moment, then the structure will not start to rotate. That's it for today. I hope you have learned something about the turning effect of forces.